Today we want to do an actual thrust test on our industrial C-series electric linear actuators. First we need to build a test shelf. Here we use some number 5 angle steel and bolts to build a stable square test frame, which is 0.5 meters long, 0.5 meters wide and 1.5 meters high, and can load up to 1,000 kilograms. Next, we install a beam on the top of the test frame, and install a linear actuator fixing bracket in the middle, so that we can fix the linear actuator on the top of the test frame. Then, we also installed a beam on the middle of the test frame, and fixed the shock absorber to the beam. We want to use a linear actuator to squeeze this shock absorber. In order to measure the thrust force when the linear actuator squeezes this shock absorber, we also need a force sensor and display module. This S-shaped force sensor can measure both tension and thrust, and its maximum range is 1,000 kilograms. The sensor has a connection line, which is directly connected to the display module. After we connect the sensor and the display module, the LED screen of the display module can display the value of the pulling or pushing force received by the sensor. The unit is kg. Here we have performed numerical corrections on them in advance. Next, we place the sensor in the middle of the shock absorber. In order to operate the linear actuator, we also need to use a power supply and a manual controller or control handle. The model number of this control handle is 004311. The control handle has 2 wires. One needs to be connected to the power supply. Here we connected to a 12 voltage 10 ampere power supply. The other line of the control handle is directly connected to the linear actuator. The control handle has 2 buttons. One button is used to operate the linear actuator to extend outward, and the other button is used to operate the linear actuator to retract inward. In order to measure the thrust force of the linear actuator, we fully retract the telescopic tube of the linear actuator in advance, then connect everything, and then we can start the measurement. We press the button of the control handle to slowly extend the linear actuator outward, and it squeezes the sensor to slowly downwards, and at the same time the value of this thrust force will be displayed on the display module. Because the speed of this industrial linear actuator is 20 mm per second, its maximum thrust force should be about 300 kgs. We actually measured it and got a real value of about 306 kgs.